this is Connor Svensson. I'm the chair of the Technical Specification Working Group in the Enterprise Ethereum Alliance and founder of BLK.io, an enterprise blockchain technology company. The Enterprise Ethereum Architecture Stack diagram was developed in order to provide a reference point for all of the different components we believe encompass the Ethereum blockchain ecosystem. Those components that aren't just relevant to public Ethereum, but also enterprise. There's 5 different layers which I'm going to be talking about, but the first thing I wanted to draw your attention to was the different colors that we're using in the stack diagram. We started off by identifying what are the core components in terms of public Ethereum technology, and those are the components that are in green and yellow. Those components in yellow are items that were actually specified in Ethereum's formal specification, the yellow paper, and those in green are components where there's active work happening in the public Ethereum ecosystem. Additionally, we have colors that we're using a purple color, which is mainly components on the right-hand side to highlight enterprise-specific components. And of course, there can be some crossover there, but we believe that the interest there is more on the enterprise application side. And then we have a light blue at the top, which is application-specific or decentralized apps and smart contracts and so on. So if we work our way up from the bottom of the diagram, at the bottom we have the network protocol there, and this contains right now, because it's focused on Ethereum 1.0 technologies, Dev P2P, and we also believe over time there'll be enterprise specific potentially communication protocols being invoked there. Then in the layer above we have the core blockchain layer, and so the thing that's worth mentioning is that these layers don't necessarily have a relationship where one needs to, a layer above another one means that the layer below it can't exist above it, so to speak. The ordering is fairly arbitrary in that respect, but we believe that the consensus is obviously a very core component here. So we have public consensus mechanisms, which in the public Ethereum network is proof of work, and so the time it will be proof of stake. And then we also have a private consensus mechanism. So this would be implementations such as Raft and IBFT. It's worth mentioning that in the public Ethereum test networks, of course, they make use of proof of authority as well. And I mean, it's used in both public and private networks in that respect, but we'd typically classify it in the bundle of a private consensus mechanism because it's intended for networks with specific nodes managing it. In the layer above, we have the execution layer, which is where the Ethereum virtual machine is, which provides all of the computation functionality. We also have the synchronization as well of nodes. So when they synchronize the blockchain from other nodes on the network, there's different strategies that they can use for that. Then there's also pre-compiled contracts as well. So those contracts which are too expensive to run as code on the Ethereum blockchain, they reside typically in Ethereum clients in a pre-compiled, therefore optimized format. The other thing that we have in this layer is trusted execution as well, which is where we actually want to have capabilities to execute code in a secure environment, and this is touched on with some of the other layers too. And moving up, we have the on-chain public state. So this is the state associated with, it could be addresses in the public Ethereum network, their balances, but then also smart contracts, the state associated with them and how that evolves over time. Then there's also the storage that's used as well. So this is again smart contracts when they're storing data that resides on the blockchain. Then there's also this notion of off-chain storage, and this is where some of your some of the technologies such as IPFS and Swarm come into it, where you have techniques for storing data actually off the blockchain in another decentralized network. And then additionally, we have on-chain private states. So this is where, as the name implies, where we have private information residing on the blockchain, which is certainly an area that's evolving with certain privacy techniques that typically use zero knowledge type techniques and maybe homomorphic encryption. Moving up, we have the privacy and scaling layer, and again, to emphasize here that neither one layer is an enabler for the other layer, so it could just easily be called the scaling and privacy layer. So on so what we have here is we have the on-chain scaling techniques. So this is typically where we would have sharding, for instance, would come into it. And then we have off-chain techniques. So this is where for instance in public Ethereum, where you'd have data being processed actually off the blockchain. Plasma could fall into this category, but given that a lot of that's using smart contracts, strictly speaking, it could be further up the stack here. But that's an example of a off-chain scaling technology. Then we have the on-chain privacy technique. So this is sort of complementary to on-chain private state that we discuss in the core blockchain layer. But these are just the various different privacy technologies that can be supported. So it could be using techniques such as ring signatures and also shielded transactions and so on to provide additional layers of privacy on the blockchain. Then we have off-chain trusted execution. So below where we talk about trusted execution, there's a notion of having trusted execution for computations that happen on the blockchain, but then there's also those that happen off-chain. So you can have a service that a node sends a transaction to for processing to outside of the blockchain, and this is what the trusted computation EEA specification speaks to. And then additionally, we have private transactions, and this is the type of private transaction that was originally conceived in the Quorum blockchain technology, whereby you have an enclave that stores details of private transactions, and this is something that's in the EEA specification, but multiple vendors now support. Moving up into the next layer, we have the tooling layer. And so here we have the client interfaces and APIs. And so at this point in time, JSON RPC is the dominant API format for talking to nodes on the network. Then there's also this notion of interchain APIs as well. And this is more of an emerging area where different blockchains can potentially transfer data to one another. And so in the nearer term, it's more about transferring potentially state or sending details of transactions across them. But the longer term technologies such as atomic swaps here could certainly fit into that. Then there's also Oracle technologies as well. So your oracles will provide your gateways to the real world. And again, there's potentially some crossover with oracles and the actual notion of off-chain trusted execution, depending on how you set up the environment, because typically oracles will use some sort of there'll be some notion of trust when they're providing data into blockchain services. The next layer up, we have the integration and deployment tools. So this is where your integration libraries such as web3.js, web3j, Ethereum, and so on that provide abstractions for working with the lower layers appear. And then there's a more general enterprise management system. So this is where over time we believe there'll be integrations with, it could be like large enterprise platforms such as your ERP systems or related systems that want to actually access, to retrieve or store data within the actual blockchain. The next layer up is where the permissioning and credentials come in. So this is where your wallet files are, your key management, your hardware security modules for actually securely storing these credentials in a safe environment, and standards around actual permissioning and authentication, so best practices for providing permissioning and authentication for for access to blockchains. Which then brings us nicely into the application layer, which is we have the smart contract tools. So this is where you have your abstractions in the form of smart contract languages, such as Solidity being the most widely known one, but also LLL or Viper, for instance, as alternatives that can be used, and the work that's been done around formal verification of these smart contracts. Then we have the actual infrastructure contracts and the standards associated with them. And so there's a number of different what are called ERCs, or Ethereum Requests for Comment, which are standards that have been created by the Ethereum community for smart contracts. And here you have a number of different concepts. Now, not all of these necessarily exist right now, but for instance, we have the ERC 20 and ERC 721 for fungible and non-fungible token standards, which have really been established as a standard in their own right, and also the Ethereum name service as well, which provides a DNS type lookup capabilities for contracts and wallets addresses on the Ethereum blockchain. But then, over time, we believe that things like role-based access control and also identity will have standards there. Then finally, we also have network governance, and this is something in the version 2.0 of the EEA specification. We actually provide network governance standards as well for smart contracts. Then the final layer is where we actually have the applications, or the decentralized apps, or dApps as they're known, that actually utilize the blockchain and work with those infrastructure contracts, or just work directly with the actual blockchain themselves. And then your more sort of business focused tools as well, like your blockchain explorers, your monitoring, analytics, business intelligence type tools. So that's an overview of the Enterprise Ethereum Architecture Stack.